What about the first question?
Just a second. Yes, sir. I'll just open my notes. Yes, sir. First question is it's geminal dihalide. Number 2.
Yeah. If it is alkyline, it is vicinal. If it is alkylidene, this is there. Means two same groups on the same carbon. Okay.
Yes, sir.
So this is gem, right? Which is a halogen exchange reaction.
Halogen exchange is number 1. Rx plus NAI gives us Ri plus NaX.
What is the name of this reaction?
Finkelstein, yeah?
Yeah, Finkelstein. This is addition reaction. While on the other hand is Finkelstein is substitution reaction. Got it? Substitution because it is one group is being replaced by another group. Okay. So it is a substitution reaction. Addition is two things get added,
Yes, sir.
and the double bond is converted to a single bond. This is a substitution reaction. We have seen that we take ZnCl2 and HCl to get OH converted to X. Okay. Next is this is also substitution reaction on benzene. So this is only the halogen exchange reaction. Next is alkyl halide are prepared from alcohol by treating it.
Sir, it's number 1, HCl plus ZnCl2.
Yeah, it can be HCl and ZnCl2 if you want to get a Cl. It can be red phosphorus and Br2, which is equivalent to PBr.
But it can't be H2SO4 plus Ki, yeah?
Yeah. Because this, especially I gave you warning that if you take H2SO4, this will not give you HI. But instead, and this is also in-text problem that we discussed, instead, it will get oxidized to I2.
Yes, sir.
So what should we take with Ki if you want to get HI, and if you want to get the OH replaced by iodine, take Ki, but don't take H2SO4. Take H3PO4. Got it?
Yes, sir. Yes, sir.
Alkyl chloride are synthesized by heating alkyl chloride and bromide in the presence of
H2F2.
Yeah.
Any metal that.
Yeah. This is
Yeah.
Schwarz
So we have
reaction.
AgF. It's not there.
Yeah.
COF2 also.
Yeah,
We can try.
Yeah.
That's it.
So that is Finkelstein reaction. So you have AgF, which is the most common of all. Okay. And then you have COF2, Hg2F2, or SVF. Two more options.
Yes, sir.
Right? The two more
Yes,
options
sir. Yes.
we are having SVF. What about the next question?
Next question, first one, C3H7Cl or CH3CH2CH2Cl plus NaI will give us CH3CH2CH2I plus NaCl, halogen exchange here.
Yeah, this is halogen exchange, Finkelstein reaction. Acetone is used because it is NaCl get precipitated and it is less solid. So that's why it is used. What about this one? Next question.
Plus SOCl2 will get C3H7Cl plus SO2 plus HCl.
Yeah, SO2 and HCl, that is the uh, one of the best method to prepare the alkyl halide. Got it? Alkyl chloride, because the byproducts are gases. What about this one? HBr peroxide.
HBr in the presence of peroxide. So the one with the least amount of hydrogen. So the bromine will go to the left one.
Bromine will go to the normally HBr is rich gets richer. Okay.
What?
Normally, if you add HBr, it is Markovnikov of addition, and as for that, rich gets richer, so H2 will come in place of where you have already have more hydrogens, and on adjacent you have
Yes.
Cl. Okay. And suppose if you take peroxide, that is anti-Markovnikov of addition, it gets reversed. Then is it clear? Without
Yes,
H2.
sir.
And if you have peroxide, H will come inside and Br will go outside. Peroxide, remember this way outside. Okay.
Yes, sir.
Br will come out.
Yes, sir.
Okay. But just a hint, but you should check at that point of time. Okay. What is the structure and all? Just to, peroxide outside means anti-Markovnikov. Okay. And what about this one?
So the other way around, yeah.
Yeah. This is without peroxide normal addition. Rich gets richer,
Yeah.
so H will come in this place, and Br is going to come in this place, right? So that I hope is clear. Okay. So let me start with the topic ahead, which we were doing, the halogen exchange method. Now we need to understand that how to prepare aryl halide. Any idea how to prepare?
How to prepare aryl halides? We have Sandmeier's reactions we had,
The
and
basic,
then
that is there, the basic one. Yeah, that comes later on. Being directly from the benzene. That is also there. You are not wrong. We are coming to that, but the initial first step. For example, suppose if we want to get a chloromethane, we need to take methane and chlorine. So suppose if we want to get benzene, what we need to take? We need to take benzene and chlorine.
chlorobenzene.
Yeah, chlorination of benzene you need to do. Okay.
Yeah, in
You
the
can put
presence
a
of.
yeah, you can put a circle or the alternate double bonds. Is it clear? Because circle, because that is basically this is you are putting the circle because that is the three double bonds are rotating. Okay, they are in resonance. That's why. Okay, and what you need to take care, you do not take sunlight. That is very important. This reaction is carried out in the dark.
Yeah.
And in the presence of Lewis acid catalyst. Anhydrous, FeCl3 anhydrous. Because if you take sunlight, you are going to get benzene hexachloride. Okay, hexachlorobenzene. So that is the addition will take place on benzene because you have double bonds. So you don't take the sunlight. Instead, you take Lewis acid catalyst. Or
Yes,
just
sir.
a catalyst is enough.
You have to take a Lewis acid catalyst, yeah?
It could be FeCl3, ElCl3. You can take, or you can take in place of this. I'm writing or Fe plus Cl2. You can take Fe also. Fe and Cl2 will react. Cl2 is the
Mm-hmm.
reagent, and you get Fe, FeCl3. Actually, FeCl3 is working, but you can work with the Fe also because that is going to form FeCl3. Ultimately, it is going to react. And you can take AlCl3 also. The
Yes,
sole
sir.
purpose of taking actually is this is the shortcut to remember. So
Mm-hmm.
in a school, how they did the mechanism also. How do they teach in the school? Some schools take mechanism, some don't.
Uh-huh.
So basically, how it has happened actually is this FeCl3. They're in the uh, photohalogenation of alkanes. Sunlight was helping the chlorine to break. In this case, it is not the sunlight, it is the catalyst FeCl which is helping
Mm-hmm.
chlorine to break and react.
Yes, sir.
So this is how it takes place.
Mm. Okay, okay, okay. Yes, I got it.
Okay. So this FeCl3 pulls apart one Cl minus because this is not having four bonds. This is incomplete octet. So it want to have the four bonds. So it breaks apart one Cl minus. The Cl plus. The Cl plus actually will go to the benzene and will pull the pi
Mm-hmm.
electrons. Because Cl plus again it is a plus charge, it needs electron, and benzene has a lot of pi electrons. So it actually get connected. There is H also which was
Okay.
not depicted earlier, now I'm showing it. The pi bond actually
Mm-hmm.
goes in the benzene, it moves out and there is a plus. Whatever the Cl plus that got neutralized, but now the plus came on the benzene. Okay. And this FeCl4 minus now come again into the picture, and this reacts with HCl and break it. So you have a chlorobenzene
Mm-hmm.
and FeCl3 catalyst just help in the reaction and doesn't get consumed. So you have
Okay.
FeCl3, got it? And this H plus and this
Yes, sir.
is this HCl. Okay, that's how it happens. Okay. So how to get chlorobenzene? What is the basic method, preliminary method?
This one from hydrocarbons by electrophilic substitution. Yeah.
Yeah, this is electrophilic aromatic substitution reaction. Because electrophile,
Mm-hmm.
this is an electrophile coming on the benzene. Benzene for temporarily it loses a pi electron because, but you need to get
Uh-huh.
back to the benzene because it is very stable. So you remove H plus to bring that pi electron back, and H plus is removed and Cl plus get attached to it. Okay, this reaction is
Yes, sir.
electrophilic aromatic substitution.
Mm-hmm. Okay. Yeah.
Got it?
Yes, sir. Yes, sir.
What happens if you carry it out for the methyl benzene?
Methyl benzene.
The methyl
Uh,
benzene is you have a CH3.
okay. So this is a para group. Yeah. So we'll get T-chlorotoluene if we are doing with chlorine.
Yeah, this is actually electron donating group. Okay,
Mm-hmm.
and there is increased electron density at the ortho and para positions. minus charge. And now you know that we discussed in the mechanism that actually the Cl plus is formed because FeCl3 breaks apart the Cl minus, you are having Cl plus formed from Cl2. Okay.
Yes, sir.
So where the Cl plus is going to come in? Is it going to come on the methyl? Is it going to come in the ortho position? This is ortho, this is meta, and this is para. The side just next to the group, the positions are known as ortho.
Okay.
And this third position with respect to the group where the group is attached, that is known as meta. These are the common names. And the position which is just opposite to a group, that is called para or P.
Okay.
Meta
Yeah.
or so because this methyl is giving its electron density, electron donating groups are orthoparadirectional. Groups having lone pair, alkyl group, they are orthoparadirectional. Got it?
Okay.
And this you know, you took Cl2 and FeCl3 will form, and that FeCl3 is going to pull the Cl minus apart and the Cl plus will come in, and Cl plus where it can attach itself most easily on this complete ring.
Para position, yeah.
Yeah, para. Remember, it is Cl plus. Plus wants electrons. Okay. Plus want electrons, right? So where the electrons are present at the ortho and para positions. I put a minus charge, some partial. This is delta means some partial negative charge. Got it?
Yes, sir. Yes, sir.
Partially negative charge. So Cl plus is the electrophile. The electrophile means electron loving species, and it can attach itself where you have electron densities. Okay. So you are going to get CH3 Cl and para also. Just remember one thing, electron donating groups are orthoparadirectional groups.
Yes, sir.
So I hope this is clear. Suppose if I don't use this Fe, and if I carry out the halogenation in the presence of sunlight, then what will happen?
Nothing will happen here.
Nothing will
If
happen on the
this
benzene, but sunlight H nu is
yeah,
used for
nothing
aliphatic.
will happen on the benzene, but with the CH3 something can happen. Whoa. Learn that also, yeah.
Yeah. So it
It will get replaced with chlorine.
yeah, it is
One hydrogen will get
it is yeah, one hydrogen will get replaced. So it is the halogenation of the alkane, not the aromatic. Aromatic halogenation is carried out in the presence of Lewis acid catalyst in the presence of tar. Okay. So this is going to be CH2Cl.
Cl and benzene is the same.
Because this is the alkyl group or aliphatic group, and this is the aromatic group, benzene. So if you want to carry out the halogenation on the side chain, alkyl chain, you are going to use chlorine and sunlight. But if you are going to attach this chlorine on the benzene, you are going to take the Cl2 along with FeCl3 or AlCl. Is that clear?
Yes, sir. Yes.
Just think of it and tell me.
It's the catalyst here. It's supposed to be FRB, FEBRT or only FE.
Yeah, it can be Fe.
Achha,
If
okay.
it is Fe, it will form FeBr3. Got it?
Okay. Mm-hmm.
So
So
that's
what will get?
Br2 you take in large amounts so that actually whatever the Fe is there, that forms FeBr3. Or if FeBr3 directly given, that is straightforward catalyst. Okay.
Mm-hmm.
So what are we
So
going to
we
get here? In place of A.
yeah we'll get bromobenzene. Yeah,
Yeah, it
in
is
this we
more.
get
And it should not be
bromobenzene.
treated as ortho meta para, okay? Because it is just a symmetrical molecule. You can put it anywhere, okay?
Mm-hmm.
You can put it anywhere. It is just a bromobenzene, right? But now it will matter. This is again the bromination. You are going to put the second bromine. Where you are going to put the second bromine with respect to the first. Either it can be in the sites adjacent position, that is ortho, or it can be at the third position with respect to Br, that is meta, or directly opposite position.
I'm guessing it has to be para. Yeah, it is para mostly.
Yeah, Br is having lone pairs. Okay, and these lone pairs actually get into the benzene. Okay, do you know this resonance?
Resonance. Yeah.
Yeah, this is known as resonance. Okay. So
Mm-hmm.
Br actually has some ideal pair of electron. Of those are known as lone pair. The lone pair overlap with the benzene by electrons, and they push the electrons of the benzene. They get into the benzene. So you have a minus charge here. You have a minus charge here. You have a minus charge here.
Mm.
So whatever the electron donating groups are there, alkyl groups, lone pair containing group, they are ortho para directing groups. Is that clear or not?
Yes, sir.
So the
Yes.
next Br plus FeBr3 and Br2 is going to give you Br plus, and that next Br plus is going to come on the ortho para. Is it clear?
Mm-hmm. Yes,
So
sir.
halogens are ortho para directing, just like methyl benzene. The halogens also
Mm-hmm.
are electron donating and they are ortho para directing. But why the Br is not getting attached to the meta position? If somebody asks you what you are going to say, meta position is vacant.
Mm-hmm. Oh
But
no!
why?
Because it doesn't have a net positive. It doesn't have a net negative charge. Yeah, that's why.
Yeah, so yeah, ortho and para, the electron density is raised. Okay. And the Br plus can get that electron easily. That's why the Br plus is getting attached to ortho and para more easily. So this is
Mm-hmm.
the major product. They are the major product which are being. And in NCRT, actually, they ask you that get the para or get the ortho. So what you are going to do? You are going to do the separation by carrying out their distillation by heating them. So whichever they ask
Yeah.
you, ortho or para, you will write them. Okay. So the next, this is the method, direct method of preparation of haloalkenes. Okay, from benzene, directly from the benzene, by carrying out its halogenation by taking the X2, which is could be Cl2 or Br2, along with Lewis acid catalyst. Okay, Lewis acid catalyst are uh, used to facilitate the breaking of halogens. Okay, this is electrophilic aromatic substitution. Direct fluorination. What do you mean by this? So fluorination, if you want to put if you want to get a fluorobenzene and if you take fluorine, that is not done directly. Means you don't attach F2 directly. Similarly, I2,
Uh-huh.
iodine is less reactive.
Yes, sir.
Iodine is unreactive. Got it? We don't get the proper yield.
Uh-huh. Yes, sir. Yes, sir. Got it. Got it.
So similarly, in alkanes also, fluorination is cannot be directly carried out by sunlight, and iodine is very unreactive, so it is not directly carried out. So what you do is you do Schwarz reaction to put the fluorine and Finkelstein reaction to put the iodine. Remember Schwarz and Finkelstein halogen exchange reaction, the one which we discussed today.
Yeah.
So you get chlorine or bromine attached, then you replace them by F or I. Similarly, here also in benzene. The reaction is almost in the backward direction, meaning it doesn't happen. It's highly unreactive. But don't get the product. So what you do, you take oxidizing agents.
Mm-hmm.
Oxidizing agents like
Okay,
HNO,
yeah.
HiO3. So they react with HI and get it converted to I2. So forcefully you are removing the product and putting the reactant, one of the reactants, or you are forcing the reaction to take place in the forward direction. You are pushing it by taking oxidizing agent
Mm-hmm. Mm. Yes, sir.
or prepare by disonium. So 11th class where you studied?
Yeah. 11th class. Hydrocarbons, we must have studied this, yeah?
Okay. No, you were with Learnivio?
Back then, no, no, no. I wasn't with Learnivio.
Pardon?
I wasn't with Learnivio back then. In my
So you
11th,
use
I didn't.
disonium. Yeah, 11th.
No, no, no. Yeah, go on.
You can tell me. Yeah, yeah, not a problem. 11th,
No,
yeah.
in 11th, I wasn't with Learnivio. That's what I was telling.
Okay, okay. Good, 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 good. So how you're finding? It's good, very good. I hope.
Yes, sir. Yes, sir. It's
Yeah.
really good actually. Yeah.
One. Yeah. Normally, one-to-one interaction is there, so that is very important. Okay. Which
Mm-hmm.
is nobody takes so much time, right? So that's good.
Yeah.
And hope you refer your friends also to Learnivio, right?
Yes, sir. Yes, sir. Yes, sir.
Okay. So
I
the
will. I will.
synthesis using diazonium salt. So what do you? So suppose direct chlorine, if you try to do it, or if you want to react benzene with fluorine, it is highly heat-giving reaction. And when there is a lot of heat, the speed it speeds up and it evolve more heat and it become uncontrollable. It become explosion, right?
Yeah.
So you don't do the direct fluorination, and neither of alkane nor of the benzene. Similarly, iodine has this
Mm-hmm.
extreme end of the problem that iodine is too lethargic, too slow. It will not react. But if somebody asks you to carry out the iodination to put I on the benzene, you are going to
Mm-hmm.
use the oxidizing agent like HNO3 and HiO3 so that they can convert and consume the HI and the forward reaction can happen. Okay. So I hope this is clear to
Okay.
you, right?
Yes, sir. Yes, sir.
Any doubts in this?
Mm-hmm. No.
Okay. So synthesis using diazonium salt, which you said Sandmeyer and Getterman, you were telling, and what is that method? Any idea?
Sandmass, yes. So when a primary aromatic amine is suspended in aqueous, I think some mineral acid, yeah. It's mostly NaNO2 plus
Yeah,
H. Yeah.
yeah. Okay, you are having the idea. So you start with
Mm-hmm.
aromatic amine, aniline.
Yeah.
Okay,
Mm-hmm.
you react it with NaNO2 plus HCl.
Okay.
Sometimes in NaNO2 plus HCl, you get HNO2 also. If you get
Mm-hmm.
HNO2 or NaNO2 plus HCl, it is one and the same thing. Getting my
Okay.
point?
Okay. Okay.
Because this HNO2 is unstable, so you mix these two NaNO2 and HCl and prepare HNO2 nitrous acid. Okay.
Mm-hmm.
You keep the temperature low between 0 to 5 degrees Celsius, and this NH2, the water get removed. There is H2 and there is O, and you have N2 plus Cl minus or whatever the acid which you have taken will form. This group is known as diazonium salt. It's a salt
Yes,
because
sir.
there is a plus and minus. Okay, this is freshly prepared diazonium salt and benzene diazonium chloride.
Yes, sir.
So next is when you have the benzene diazonium chloride,
Mm-hmm.
you have this N2 group. Okay, this N2 group is a very good. It is a very stable group. It can come out and exist in atmosphere. You know that we have 70% nitrogen. Okay, lot of nitrogen is there. So nitrogen is a very stable group. That's what I want to say. This nitrogen can break apart and it can come out. Got it? So in place of nitrogen, you have an advantage to put the group of your desire, okay, which you want to. Suppose if I want to bring in the chlorine, I can take 2
Mm-hmm.
plus chloride, CuCl and HCl.
Okay.
You can, if you heat now, you can heat. Okay. You can bring the cuprous chloride, or it can exist as a dimer and HCl. If you heat it, the N2 is a good gas. It will get liberated, and you will have chlorine being attached in place of N2. So this is indirect method, not the directly. You are not putting the chlorine. Instead, you substituted that. First you had aniline, NH2 group. You converted it into diazonium, N2 plus. N2 plus came out and break apart as N2 gas. Got it? Nitrogen, right? So this is known as
Yes, sir.
Sandmeyer reaction. This is Sandmeyer.
Okay.
Suppose if you just take copper powder
Okay.
and HCl heat, what's the name of this reaction? This is Getterman reaction.
Catterman reaction. Okay.
So both are similar. Okay, just if you use copper powder, okay, Getterman. If you are using cuprous salt and HX, you can put the Br also, right? So Cu2Br2 and HBr, and in this place Cl will come. So you are going to get a chlorine. Is it clear or not?
Yes, sir. Yes, sir.
Now the problem is how to get iodine and fluorine in place of diazonium. So you start with aniline, convert it into diazonium, NaNO2 and HCl, or NaNO2. If you want to bring in the HF, you can take first keep the low temperature, then you can increase the temperature later. Let the
Okay.
diazonium salt form. So you have a diazonium N2 plus, and because you have taken this BF3 and this is BF4 minus. Or if you have taken Cl, you can heat it with HBF4. That also you can write in the next step. If you heat it, you are going to have fluorovenene, which was not directly possible because it was not able to control the reaction. Got it?
Yes, sir. Yes, sir.
And suppose if you want to get iodobenzene, what you are going to do? You are going to have the diazonium salt (0 to 5 degrees Celsius). Heat it with Ki, just like acetone, Ki acetone. This is the heating of the diazonium salt with Ki. So what will come in place of N2 plus? N2 will come out. What will come in? Got it? Iodobenzene.
Yes, sir. Yes, sir. Iodobenzene. Okay. Okay.
So it is the preparation of iodobenzene via diazonium and fluorobenzene via diazonium.
Mm-hmm.
Okay, this is known as for fluorobenzene Sussman reaction. And for chlorine and bromine, you can either put them directly. This is the direct way of putting chlorine by taking chlorine along with Lewis acid catalyst, or you can indirectly bring in the chlorine or bromine by from the aniline you can substitute it and get the diazonium, and diazonium you can replace it by Cl or Br. Okay, got it?
Mhm.
Is it
Yes,
clear?
sir.
So this is the synthesis using diazonium. Is it clear? So now we move on to the properties of alkyl halide. What kind of reaction do they give? So this is also the preparation. So can you tell me what kind of reaction do they give? What do you expect from their structure? Right, right.
What's the question, sir? Sorry.
What type of chemical reactions you can expect from alkyl halides?
From alkyl halides, well, you can expect nucleophilic substitution. You can expect
Yes.
electrophilic substitution. I
Is
think
it
so.
electrophilic or nucleophilic?
Nucleophilic.
Why nucleophilic?
Hmm?
Why nucleophilic you expect?
Well, nucleophilic because nuclear. Oh, okay. Because nucleophile is nucleophiles are they're electron rich. Yeah. So they attack the part which is more deficient, electron deficient. That's what
Yeah.
happens.
So what you can expect three types of reactions. What are those three types of reactions? One, this is the alkyl halide, alkyl group and the halide group X. You write some species which carries lone pair. Okay, this is the general representation. Are you getting my point? This could be NH3, this could be Cn minus. Okay, so this is carrying a lone pair which has ideal pair of electron, and this can come and get attached to the alkyl group, and the halogen can come out. So this type of reaction is known as nucleophilic substitution reaction. Is that clear? The other type of reaction is elimination reaction.
Mm-hmm.
What do you mean by elimination? If you heat the alcohol, if you heat the alkyl halide
Yeah.
with base, okay, alcoholic base means base dissolved in ALC means alcoholic KOH. You put dissolve the base in alcohol. Okay, you heat them, and base can react with HBr. HBr is removed. So if H is removed, Br is removed, what will happen to these two bonds? They will get connected among themselves and form a double bond. Got it? What is being removed?
Mm-hmm.
What is removed from the reactant? Tell me. What is removed from the reactant?
What is removed from the reactant?
Yeah, bromoethane.
CH2, CH2, HBr.
Compare the reactant and the product.
Oxygen is there. Okay, 1, 2, 3, 4, 5,
Yeah,
2, 3, 4, 5,
reactant and
6.
product. No, you have CH2, CH2, okay, H and Br were there. I have put a box around the HBr. What it means
Okay. So the HBr, it.
is
Oh, no,
removed.
no, no. Yeah, yeah,
That
yeah,
is,
yeah. Yeah,
and what
HBr
will
is
happen
removed.
to these two bonds which are connected to HBr? What will happen to them?
They'll form a double bond with the
They
carbon.
form a double bond, yeah. So
Yeah.
elimination means elimination of two groups from the adjacent carbon atom, leading to the formation of an alkene. Got it?
Yes, sir.
Is that clear or what?
Mm-hmm.
So this is an elimination reaction. So alkyl halide can undergo elimination reaction by heating with a base.
Yes, sir.
There is reaction with metals. Suppose if you take an alkyl halide, let's say CH3Cl, and if you heat it with magnesium, you are going to get CH3MgCl. We will get into the details. So this is known as Grignard. And this is formed by reaction of alkyl halide with metal. Insertion of metal into the carbon chlorine bond. Is it clear?
Yes, sir. Yes, sir. Yes, sir.
So there are three types of reactions mainly given by alkyl halides. Okay. They are
Uh-huh.
elimination reaction, nucleophilic substitution reactions, reaction with metals. Got it?
Yes, sir.
So why alkyl halide undergo nucleophilic substitution reaction? Any idea?
Uh, I don't know. Why?
If you look at the structure, can you tell me the distribution of charges on carbon and chlorine? If you can tell me that, then we can figure out why they react with nucleophile.
So the CH bond, yeah, as a whole, the CH bond is polar. No, wait, the
The
C,
CX bond is
C,
polar. So
yeah.
CH3Cl if you take.
So it's polar.
Hmm.
So the chlorine has a more electronegative charge. No, is more electronegative than the carbon. So it will
What do
try
you mean
to
by
take the,
electronegative? Mm-hmm.
which means it's more electron rich.
It is actually have a tendency to pull the electron towards itself.
Yeah.
So
Yeah, that's what I was
this
saying. It
electron,
has a
the
tendency
pair
to
of
pull
electron
electrons.
will yeah, it will not be in the middle. It will be shifted towards the chlorine. And
Yeah.
because it is shifted toward the chlorine, chlorine will have slightly more negative electron density. This is slightly means delta. Small delta means slight negative charge, and there is a slight positive charge over here.
Mm-hmm.
So this is a polar bond. What do you mean by polar?
Polar, it
Take the
means
charge
it has two
separation.
different charges. Like it's a system of two different charges.
halogens are more electronegative atoms.
Yeah.
So they have a tendency to pull the electron pair. And this is the root cause for the type of reactions which we are seeing. Suppose if you take a molecule or ion which is negatively charged, I am representing it in a general way, and it carries a pair of electron which is sitting ideally, means lone pair. Like there are many molecules on it, like of this. Can you give me some example of these kind of molecules and what these type of molecules are known as?
New, like OH minus, for example, we have
OH minus, yes, exactly. And
nitrogen group.
and
Nitrogen.
nitrogen means NH2 minus you can take, or ammonia you can take.
Yeah,
Ammonia without
yeah.
negative, it has lone pair.
Mhm.
Okay. And
And that's the only ones I can think of for now.
yes, suppose you
Um,
have cyanide and
yeah, cyanide, C triple bond N.
if you have any negatively charged H minus, okay, if you have CH3 minus, right,
Yeah.
if you have SH minus, just like OH you have SH. So there are many groups, NO2 minus, which carry negative charge and which have ideal lone pairs. So they are ready to share their pair of electron with other molecules. Because they
Uh-huh.
are having electron, they can get attached to the positive end of the other molecules.
Mm. Yes, sir.
So out of this CH3Cl, which end will act as an acceptor of lone electrons or lone pairs? The carbon end is going to accept the electrons, or the chlorine end is going to accept the electrons?
The chlorine end. Yeah, the chlorine end will accept the electrons
So
because it has a tendency to.
chlorine is internally, it is accepting the electrons, it has pulled the electrons,
No,
but
no, no.
now
Wait.
it has
The
negative
carbon will
charge.
accept.
It is going to be the carbon,
Accepted by the carbon. Yeah.
because it is positive. So positive end
Mm-hmm.
is going to attract the electrons. It was not able to
Yeah.
retain its own electron, they are being taken away by the Cl. Okay. Now the positive end is going to attract the electron from outside. Is it clear? From other
Yes,
nucleophiles.
sir.
Okay, these are the nucleophiles. And they will come in, and this is the general way to represent it. Okay, you are putting an arrow from donor to acceptor. Okay,
Mm-hmm.
carbon, if it accepts electron, okay, what will happen?
I'm sorry, sir. What's the question?
Yeah, suppose this is OH minus. Okay.
Uh-huh. Okay, then. So
This,
this OH minus. No,
this
because we learned this in school, yeah. So that's what I'm telling. It'll form a SN1. No, SN2 mechanism, yeah.
yeah, this is it.
So
So OH
is this
minus is
SN2?
basically the nucleophile.
Yeah. Okay, then. So what we'll get? We'll get CH3OH plus NaCl. That's what will happen.
I think there is some error happening in the just a second. Let's make a new file. Suppose, and this new file is actually, we are going to discuss nucleophilic substitution here. Just a second. Some error has come up in my notepad. Yeah, now tell me. Right, right.
Yeah. It will form CH3 OH.
Yes, how it will happen?
Okay, how it will happen? So it will attack from like how it will happen. So in here the NaOH molecule. So the OH minus, because of the steric hindrance of the Cl molecule, it will attack from the other side, from the opposite side of the Cl molecule. So we'll get an intermediate with OH and Cl and 3 hydrogen attached. Is that right?
Yeah.
And
So
then
you need to, yeah,
the
approximately you are telling whatever you are telling is correct. Just we need to little bit fine tune it, right?
Mhm.
Is it clear?
Yes, yes.
So that is correct, whatever you are telling. So why this OH minus, this is negative and this is positive, right? OH minus from the NaOH will get attached. Where they will get attached? It will get attracted to the positive end of the dipole, right?
Okay.
And carbon can make how many bonds? 4 bonds or 5 bonds. Maximum number of bonds formed by the CH3Cl. It's carbon of CH3Cl. How many they can be? 4 or 5. Yeah, right.
What's that?
How many bonds carbon can make? 4 bonds or 5 bonds?
4. Maximum 4. Maximum 4.
Maximum 4. So if this
Yeah.
OH minus is coming in with a pair of electron and giving its pair of electron to the carbon, someone has to leave. Got it? Are you getting my point? And who is going to come out and how? The Cl is going to come out. Is it clear or not?
Yes, sir. Yes, sir. Clear, clear.
So this is known as nucleophile. This is known as substrate. What is substrate?
Substrate. Substrate is the object on which the reaction is happening, the compound on which the reaction is happening.
Yeah, on which the reaction is happening. This Cl
Yeah.
minus, this is the product. The OH will get attached from the other side, back side of with respect to Cl. Got it? And the Cl minus is going to come out. It is pushed out by the OH minus. This is the leaving group. This is the product. So this is pushing off one group by another group, substitution happening, and this is nucleophilic substitution. Why it is nucleophilic substitution? Because the group which came in carried its own electron pair with it, okay, and that's how it was able to push another group with its electron pair. Got it? Because OH is can't get Cl, if it comes out, it will take away the bonded electron pair with itself, and the OH is going to get attached. This is nucleophilic substitution reaction. Is it clear? How it will be happening? This is just a single step reaction. What I
Mhm.
have written, what does this mean? Just try to explain me.
Single step bimolecular, which means that two molecules are involved in this reaction in only one step.
Yeah, in
Is that
one
right?
step. By yeah, exactly. Very good. Bimolecular means two molecules are colliding. They are involved in the main step of the reaction. Bimolecular nucleophilic substitution reaction.
Mm-hmm.
What's the abbreviated name of this?
SN, this
Yeah,
is bimolecular. So SN2, SN2.
yeah. Substitution nucleophilic bimolecular means it is substitution. One group being replaced by another group with the help of the
Mm-hmm.
nucleophile. This is happening, which was the OH minus or CN minus, or you can have a lot of many nucleophiles. When two molecules are colliding, one the substrate molecule, another is the nucleophile. They are colliding with each other. That's why it is a bimolecular nucleophilic substitution reaction. Got it? SN2. Okay. So this is a very important, and alkyl halides are good substrates for substitution reaction. Why? Why alkyl halide can undergo substitution reaction so easily? What could be the reason? Tell me.
What's it?
What could be the reason why the substitution reaction can happen so easily on this alkyl halides? Why? Because
Because they have no, because they have a tendency to accept the
electron pair, because the carbon
yeah.
connected to halogen is having a positive charge.
Mm-hmm.
That's why it can be attacked by a nucleophile. Are you getting my?
Yeah. Yeah.
If it gets attacked by a nucleophile, means it can undergo substitution reaction easily, right? So this I hope is clear to you. Got it?
Yes, sir. Yes, sir.
So bimolecular nucleophilic substitution reaction SN2, and what will be the rate? Let's get back. Let's talk something about the kinetics,
Chemical kinetics. Okay.
because that is in part of this chapter also. Part of it. So rate is actually because the two molecules are colliding with one another, and definitely their concentrations are going to affect the speed. So rate is directly proportional to the concentration of the substrate as well as the nucleophile.
Mm-hmm.
Are you getting my point or
So
not?
it depends on the concentration of both the substrate and the nucleophile.
If I yeah, because if you increase the concentration of both of them, they are colliding with each other. More collisions are going to happen. More the reaction is going to occur with more speed. Okay, so that's why it is said that the rate is equal to, this is constant, times the
Mm-hmm.
concentration of the substrate into concentration of the nucleophile. Both affect the rate of the
Okay.
reaction. Is that clear?
Okay, sir. Yes, sir. Yes, sir. What's K? What's K?
K, K is the rate constant. Because I have removed the proportionality sign, we need to put a K.
Okay.
That is called constant. That
Okay.
its
Uh,
value is equal to the rate when each of them is taken as 1 mole. So if each one of them is taken as 1 mole, the rate will be equal to K.
Okay, sir. Sir, can I come after like 5 minutes? Because I have to 3 to 5 minutes. Yeah.
Yeah, okay. Okay.
Okay. Yeah.
Just
Yeah,
yes,
because we have to pray. Yeah. So just 3 minutes.
yeah, just be quick. Yeah. Okay. So what are the examples of biomolecular substitution reactions, SN2 reactions?
Yes, sir. I just came back from the break. Examples of
SN2
SN2
reaction.
reaction. Well, we just did one, so there's that one. CH3Cl plus OH minus.
Yeah, they are very easy. So suppose if you have CH3Cl and if you take KOH aqueous,
Mm-hmm.
just now we have seen that the OH minus is going to come in and Cl minus will be ejected. So you will have CH3OH and KCl. Got it? Suppose if I take KCl, what is going to happen? If I take KCl, this is K plus and Cl minus. Then you have AgCl,
Mm-hmm.
Ag plus and Cl minus. Okay. You just in the last class we have seen Ki and acetone. This you only told me today in the assignment.
Yeah.
NH3 heat. Next you have KH, which is the nucleophile. Yeah, Ibrahim.
So these are all examples of nucleophilic substitution, yeah?
But you need to tell me the products also.
Okay.
You need
Okay.
to identify the nucleophile and tell me the product.
Okay. So the nucleophile is mostly what? Negatively charged, yeah.
Yeah.
It
So which
it is
nucleophile
mostly
is there
negatively
and
charged.
what is the corresponding product which we are going to get? Are you getting
Okay then.
what I am trying
Yeah.
to
Yeah, yeah,
draw?
yeah, yeah, yeah.
So many of you already told me. You know it very well. So just tell me again.
Mm-hmm. So for the first one, K plus C minus and cyanide. So cyanide will be our nucleophile. Is that right? Yeah, okay.
Yeah, the
So
carbon end of the cyanide.
yeah, the carbon end of the cyanide is it's the it's the nucleophile.
Nucleophile.
So
So
it
that
will
carbon is
attack
going
on the
to,
carbon.
yeah, CH3.
So it will attack on the carbon. So what we get? We get CH3 bonded with C triple bond N with cyanide plus KCl.
Yeah. And leaving the Cl minus will be pushed out.
Yeah, plus KCl. Is that right? Okay.
Yeah. Or KCl you can write.
Okay.
What
Okay.
about this one?
Same thing. CH3 C triple bond N plus AgCl.
but there is a slight change.
AG. Okay.
And why there is a change?
Won't we get? Oh wait, no. S. It can't be Swartz reaction. I thought this would be Swartz reaction.
No, actually, what happens is this silver actually makes a covalent bond with the carbon.
Covalent bond. Okay.
So what happens is the carbon now is not free to attack. Getting my point? Carbon is not free to attack. Why? Are you getting my point or not?
Yeah.
Because carbon is bound with the Ag plus. So now what?
Yeah.
Though it is a
So
nucleophile, but that is nucleophilic end minus charge is bound to Ag plus. So can it go and attack or attach itself?
no, it can't. It can't. So maybe the whole thing will get attached to the carbon. Can you do that?
But there is another route. There is one more place where you have a lone pair.
Oh, okay, on the right side. Okay, so it can attack from both sides, yeah?
Yeah, this is known as ambidentate nucleophile.
So what we get, CH3 bonded with nitrogen, triple bond, C.
Exactly. Exactly. Very good.
Mm-hmm.
So this is isocyanide. Or isonitrile. That was cyanide or nitrile. This is the
Isocyanide.
reverse. It is attached in the reverse way. So it is isocyanide. Got it? It happens with aging. Same thing you can apply here also.
Mm-hmm.
KNO2 and AgNO2. First, I will write them in a normal way. And this is the thing which most of the students do mistake in this. But very simple thing, you also understood what is happening. Such nucleophiles are known as ambidentate.
Okay, yeah.
They have teeth on both the sides. Teeth means actually the lone pair. Got it?
Mm-hmm. Mm-hmm.
Ambidentate nucleophiles. So similarly, you can think of KNO2 and AgNO2 in the same way. Tell me what
KI
they have.
and acid. Uh, which one we are doing next? KI and acetone?
Yeah, this is just a simple one. You already told me in the first
Oh,
assignment.
yeah.
Okay. Okay. This
On
is that
heating with.
Haloalkenes Finkelstein. Okay.
Yeah, Finkelstein.
So
Next
this
up, we'll
is
have.
PI and KC.
Yeah, we did.
What will happen if you put ammonia, NH3, as a nucleophile?
NH3. So all the value. No, wait. Carbon, nitrogen will have one lone pair. Yeah,
Hmm.
nitrogen will have a lone pair.
Yeah.
Okay, so CH3 bonded with NH3. No, wait, no. Yeah.
Actually, CH3, NH3 plus will come up and that H plus it will lose. So CH3, NH3. I will write minus HCl. Once the nitrogen get attached, it has a plus charge. to remove the H plus to make it neutral. Is it clear?
Mm-hmm. Yeah, yeah.
What about this
Yes,
KH?
yes.
What is
KH, both are positive. So,
so K plus
K,
K plus
mm-hmm.
the
Will
one
it
which is
be
on the
H
right hand
minus?
side in the periodic table that will be positive, and one which is more right hand side and lower down which is positive. So H
Okay,
minus.
then. So you get
Potassium
CH4.
hydride. Yeah, CH4 exactly. Very
Mhm.
good. H minus is going to come in for CH3H
Yeah.
and KC. So this is basically the potassium hydride. The name you know now. Okay. Now these two are same as that of the one which we discussed, ambidentate nucleophiles. The one with two teeth on both the sides. Hmm. So what will happen with KNO2 and AgNO2? KNO2 and AgNO2.
Mm-hmm.
Tell me. Same
K
kind of
and
thing. NO2 is like
yeah,
this.
yeah, yeah.
You have KNO2. Yeah, tell me now. If I am getting a point,
Mm-hmm, mm-hmm. Yeah, 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 yeah.
tell me.
So the nitrogen, it has a double bond in there. So we can't like, no, wait, no, we can.
Actually, by default, the
Mm-hmm.
atom which is having a negative charge will attack.
Okay.
That is the nucleophilic end. Got it?
Okay. So can't we write this as CH3 bonded with O, double bond N? We can like make it inverted.
Yeah,
CH3
CH3O
O,
and
double
O.
bond. Yeah, yeah. We can do it like that.
So this is called methyl nitride. Alkyl nitride. ON. Correct. Now,
Yeah.
what about AgNO2? Same thing, I gave you the hint. Silver has a tendency to form some covalent bonds.
Yeah.
I've shown. So is the oxygen now free?
Which oxygen? The one on the left or the one on the right?
The one on connected to Ag, is it now free?
Well, no. No,
Why?
yeah, yes.
Because it
Yes,
is
it is free because it doesn't have a covalent bond here anymore.
no, this one. I'm talking about this in
I
AgNO2.
think it is free.
Is it as free as potassium nitrite KNO2? That was completely ionic. Got it?
Yeah.
So ONO2 was free. The once you put it in the solution, K plus separated out, ONO moved different way, O minus was minus, so that is more desperate to attack, and that was the attacking end of the molecule. Got it?
Yeah.
What about this one? Now the ONO is not as free as it was in KNO2, because silver plus has a tendency to form pi bond. So not pi bond, actually covalent character, covalent bond, not partial, not complete, but partially it will try to bind itself to the O minus. Now O is not available. Nitrogen is available. Attached state, same thing here also. We have seen the nitrogen was available here also, the nitrogen. So in silver salt, nitrogen is the attacking atom. You can write it.
Okay.
So what you are going to get the product in this place? Tell me. You told me this product
Won't it
very
be the same?
correctly. Now at this
Won't
position,
it be the same? It's supposed to be the same.
no, the formula is going to be same, but the connections are going to be different.
Yes, the connections will be different. I think it instead of like no, it will go down. Like the bond, it will go down.
The
Is
nitrogen
that
is going
correct?
to get, nitrogen will be the attacking atom, okay, on the methyl. So what I'm going to write over here is CH3, nitrogen is the attacking atom, and leave it as it is. It's called nitromethyl. Got it? Is it clear? So it has attacked from the middle atom like this. So, and then KNO2 it attack like this. So ONO. And then AgNO2 it attack like this. In the middle nitrogen got attached to the methyl, because that carried a lone pair, and that lone pair attacked on the methyl. Are you getting a point or not?
Yeah.
What a very important reaction. It has been asked in many places, and most of the students make mistakes. So, but that is good. You in the first attempt you hold many right answers. Okay. But do keep this in mind. This is a bit tricky. These two examples, CN and ONO, they are examples of ambidentate nucleophiles. So what are ambidentate nucleophiles?
Ambident nucleophiles, like no, like they can attack from both sides.
Yeah, they carry lone pair on two sides. Why they get attacked on both
Yeah.
sides? What makes them attached? Because they carry lone pair on two of their sides, or two different atoms in the same molecule. So either they can attack in a they can attach themselves or attack on the carbon atom in two different ways. If it is a silver salt, then the nitrogen will be attacking it. Okay. In this case, we have seen in this case. So I hope this is clear.
Yes, sir. Yes, sir.
This is SN2 reaction. Today we have covered a lot of very important reactions. Okay. So just revise them, responded very well, and I want you to maintain this level, okay, throughout. Okay. So let me end the class and let's discuss more questions like this in the next class. So let me end the class. Bye bye.